if you read around in the literature, this difference between tying collapses to measurements and tying them to observations and then tying observations to consciousness, that comes up in the literature. So somebody like Everett or some of these people who appeal to measurement then go on and insist, look, you don't have to be conscious to be a measuring device. I mean, there's no problem with making a robot, right? A mechanical robot measuring device. So don't, saddle me with this Wagnerian invocation of, the mind-body problem. Whereas, as far as I know, what Wigner wanted to do was invoke the mind-body problem, in sort of the way that, I don't know, Penrose wanted to invoke Gödel's theorem as the key to something or other. And these are just very different attitudes about what people think they're doing, even if they're all doing things that have kind of no hope of being really principled. They have no hope in different directions.
So they're quite different approaches. They share in a very similar kind of futility and hopelessness. Right.
Well, the elucidation is helpful, but where I was going is, we've already seen how things like, or terms like the Copenhagen interpretation or measurement can be obscuring rather than helpful. And for better or for worse, the von Neumann-Wigner interpretation as a term is used interchangeably with something like consciousness causes collapse interpretation.
I've never actually heard.
I wasn't aware of that.
Yeah, I've never. Who uses the phrase the von Neumann-Wigner interpretation?
Right.
I will Google it right now, and because I know that I've seen it.
It's not widely used, I can guarantee that.
Von Neumann. Yeah, there's a Wikipedia page on the von Neumann-Wigner interpretation. It's quite extensive.
Go figure.
Yeah,
David Chalmers.
About Wikipedia at this point.
Well, David Chalmers is cited as a big part in this, apparently. But anyway, my question was going to be, though, is what your motivation earlier in your career, Tim, was to pursue this, and also to ask David what the sorts of experiments that Abner Shimoni was doing.
Well, look, when I was growing up, people were reading the Tao of Physics and God knows what. There was just this zeitgeist that there was something ineluctably weird and spooky and profound or whatever about quantum theory in all kinds of strange directions. And I was a young kid, right? I was some naive little guy who thought, gee, that sounds cool. Once you get into it, and then especially once you read somebody like Bell, it kind of blows all of these clouds away. And you say, look, there is a definite technical problem here. We don't have a clearly defined physical theory. And interestingly enough, it's to the opposite of Bohr, and this is what we've been saying all along, to the opposite of Bohr's idea that there just can't be one. When you start looking into it, you say not only can there be one, there can be several that are all quite different, but are clearly articulated, mathematically formulated, and empirically adequate as far as we know. So, and none of them involve consciousness, and none of them involve, some of this really weird stuff. Now, you might end up being disappointed by that. I wasn't disappointed by it. I just found it, the more I got into it, the more interesting it was. And you're puzzled that there's all of this obscurantism around the subject matter when there shouldn't be. That's how I got to where I am. But Bell's result does tell you something quite astonishing. On the other side, when I read Bell's theorem, I understood, man, this I really was not expecting. I didn't see this coming at all. And this really looks like something you can take to the bank. And that's what I've been kind of hammering on for 40 years.
David, did you have anything to say regarding what you mentioned about Shimoni?
Shimoni, I remember, experiments of Shimoni's, and these would involve departures from Wigner's point of view. But I remember experiments in which Shimoni, if I'm remembering them correctly, asked some graduate students to try mentally, whatever that means exactly, to delay or to speed up the decay of a radioactive nucleus. Okay, and what I remember being astonishing about the outcome of this experiment is that they had a lot of runs. Okay, and it wasn't just that they didn't discover an effect of trying to speed it up or slow it down, but the actual measured frequency was exactly the predicted highest probability value. And I remember being in an audience where Yakira Haronov was listening to this result, and Aronov stood up and said, "That's astounding. There's something really mysterious here, because the probability that the frequency would exactly match the probability was incredibly low. So you must have made some astounding discovery." But anyway, yeah, people ran experiments like this in the 60s, especially people like Abner, who were working closely with Wigner.
That just shows that the universe is so designed that it will maximally not do what you want it to do, but be able to do that.
Right. Something funny is going on, right? That's what Yakir said. Yakir said, "My God, this is astounding." Okay, it matches it exactly. Something really funny is going on. But this, of course, was a joke. The result was there was no measured effect.